Hi everyone, I'm Shakil Ahmed. Today we'll be exploring how we can use the cutting edge biosensor within the extended realities to make our construction work more safer and more efficient. So extended reality or XR is an umbrella term that's used for um, referring the virtual reality, augmented reality, and mixed reality. And what is a biosensor? Biosensor is a wearable and embedded device that detect and record the physiological data from the human body. We're familiar with the core and long-lasting challenges in our construction industry. That's safety risk, productivity, the constant need for better training, and our traditional methods are failing behind. So we're looking for new technologies for that. And we know that XR is like already changing the game in manufacturing and automation. What if we could make XR even smarter? What if the system knew when a worker was stressed, tired, or not paying attention? That's where actually the biosensors come in. By measuring things like brain activity, heart rate, mental workload, we can get the real-time worker's physiological state and can create truly adaptive and intelligent system. So, what is the objectives? Objectives of this review was to explore how this multimodal biosensor can specifically enhance the XR environment or system within the construction industry context. And to do so, we are focusing six key areas in the construction: safety, trace and fatigue, cognitive, ergonomics, human-centered design, and framework and standard. To ensure the systematic and comprehensive review, this study followed Prisma methodology, starting with a broad source across Scopus, Web of Science, Google Scholar, using like carefully constructed keyword that intersecting the construction, XR environment, and wide range of biosensor. And this initial source yielded 67 publications after applying three criteria that studies had to be truly multimodal. That's mean using more than one biosensor, and they had to be like studied in XR environment and published between 2022 to 2025 because we are focusing on the recent publications. And after carefully reviewing the title and the abstract, we got 34 actually publications. And after full text review and assess the relevancy of this study to this review, that resulted in 20 actually final publication that's from the basics of this review. I'll walking you through the highlights of this publication now. So you can see from this graph that the publication trends showing a clear and accelerating interest in this field. The number of high quality publication is growing. What that's mean? That's mean this is the very active area of research. Furthermore, the research is being published across the diverse set of conference, journals, reports from like core construction journal like automation and construction, construction engineering and management, to safety science, biosensor, or neuroscience. And this actually highlights the truly interdisciplinary nature of this work. And later in this presentation, I'll discuss how this cross domain coming together, integrating together, and making the innovative, nice, magical system. Let's quickly demystify the technologies. When we say biosensor, what are we talking about? So there are several types we can find from the selected publications. That's ECGs, eye tracking, skin temperature sensor, GSR, and flex sensor, cortisol, and so many. But broadly, we can say that we can divide it all of this biosensor into three groups: sensor for brain, sensor for body response, and sensor for movement. And here in this graph you can see that the frequency of using the biosensor in the selected publications, when we can see the EEZ, that's for brain activity measurement, EDA and GSRS from skin conductance, temperature, sweating measurement things, heart rate variabilities. These are the sensor frequently used within the selected study. Okay, let's go into the final findings. So how does this works in practice? So let's start with the safety training and hazard. Okay, so one of the study from Choi et al. Actually, they put worker in a VR scaffolding simulation by using EEG to monitor brainwave and tracking their eye movement by gas matrix. Actually, they could predict with high accuracy which worker could fail to recognize the hazard or risk. Imagine that before anyone even step on the real construction site, we could identify who needs more training and on what specific risk actually. And the other study, Durian et al. Actually, they use the powerful combination of so many sensors, sensor fusion. By combining all this EEG, ECG, GSR, and skin temperature, they are able to classify worker risk of falling from the height with a like outstanding accuracy, like 99%. This shows that more comprehensively we measure a worker's physiological state. With this like comprehensive data, we can better predict critical safety event. What about the cognitive load and learning assessment? So studies by Quinn and Bulbul, they showed that's an extraordinary study. They showed that augmented reality glasses to guide assembly the tasks reduce a worker's uh, mental workload by 18% compared to the using the 2D drawing. So what does mean? That's mean um, we measuring the brain activity. We can clearly say that the AR or VR they're helping the worker, and this means the workers can learn faster, they can make fewer mistakes, they can feel less stressed. And another study, Ho et al., their study actually using a modern AI. They used a HoloLens and a simple heart rate monitoring by applying a sophisticated transformer AI model called CL transformer. They could detect the cognitive load with excellent accuracy, 96% almost. And most importantly, they proved that the high cognitive load was not just a feeling. It made the task like take yeah, more time, almost 50% longer, and increase the user's stress or cognitive load. Okay, let's talk about the stress and fatigue detection. So we can say here this two study, Zhang and Albano, their study shows that um, flying drone actually with close proximity to the worker or when a robot moves so quickly near to them, that's actually spike the stress level of the worker. And also Teherani showed that with the VR model and EEZ that elevation is a can be a good factor that's increase the stress of a worker. So this measurement is not a guesswork anymore. Actually, we can design safer human robot interaction based on the real physiological data. And ergonomics and task productivity. So this study, Gauss. So using simple motion sensor. That system can automatically track the worker's activity, count repetitive tasks, and detect the false status with 99% accuracy. And this allow for real-time ergonomics feedback to prevent injuries and provide data to optimize workflow on the site. And the other study, Kim et al., this study actually build the hardware to feel them. So they design a wireless gloves with pressure sensor that measure the physiological pinching force or pressure uh, that's correlate to the like real world. And this is the critical actually for realistic ergonomics analysis and skill training. Now we'll talk about human-centered design and decision makings. And here you can see that Sun et al. Their study actually shows that architects are now using VR work to where they track person's emotional response to a space using eye tracking and heart rate. They can objectively can like tell which design feels less stressful or more intuitive. This is a human-centered design driven by data, not by like any service. And standard and implementation framework. So Zagoli and Sons, they actually review a massive number, like more than 500 studies, and found a critical gap that less than 20% of them actually use the biosensor data to um, provide real-time adaptive feedback. And the field is like great to collecting data, but not at acting on it. So this this study directly highlight that urgent need for the standardized framework so we can move from lab environment to uh, experiment to reliable practical applications like human-centered design shown by this study actually Jill and Race. So their study actually set up with the EDA heart monitoring GPS sensor to assess the pedestrian trace in urban simulation. And this kind of result is kind of like emotional heat map of design. For construction, this is incredibly relevant. You can you could plan safer site layout or design public space that are demonstrate that less stressful for the occupant or the worker who are working on the site. Okay, so now we'll talk about the cross-domain integration. So there's so many cross-domain integration, but I only will talk about only three. That's neuroscience, machine learning, and XR designs. So we're using AI model here in Choi et al. And Hu et al. For both, using AI model to translate the new raw sensor data into meaningful classification. And their accuracy is outstanding, like 95%, 99%. The other type of cross domain is like XR environment, real-time behavior, safety, and artificial intelligence. And here we can see that this is about creating an automatic safety system that can detect workers' behavior, their motion track, and predict their um, they're at risk or not. They're like possibilities of falling from height. The other type is biomechanics, XR environment, and design decision. This close the loop actually. They're using biomechanics like eye tracking, smart gloves to assess the physiological state of worker, and to do so um, using data of physical and emotional response to create better or more human-centered designs and tools. So what are the significance and implications? So, what does all this mean for us actually? Like, firstly, it's about our people who are working in the construction industry. We can move to a truly human centered approach, understanding our workers' well being in a way we never could before. It means enhanced safety. Um, we can create adaptive safety alert and prevent incident before they happen. It means improve productivity. We can optimize tasks and reduce physiological strain. And it means smarter training. We can deliver personalized training that makes the worker more aware about the hazard and risk in the construction side, and also they can make them skilled on their work. So in the conclusion, we can say integrating biosensor with XR is not science fiction anymore. It's transformative opportunity that is being proven by all of many of these research we discussed today. It has the potential to fundamentally change how we can manage safety, training, productivity, design, decision making skill. So while there are still challenges to solve around standard and deployment, but the potential is undeniable. So I think the clear next step is to move from research to reality, and researchers like us, we should explore the focus pilot project to test this application in our own environment and make them prove that we can use it in our industry safely, reliably. Okay, here's the reference. I have included the full list of reference for anyone who would like to dive deeper into the research. And thank you. That's all.